Today we start from one important topics related to non-linear space. Also discussed in previous class also. But today we start this one. We start from closed wall and open wall. Okay. Closed wall and open wall. Let XD be a matrix space. A belongs to X and R greater than 0. Then a closed wall with center A and radius R is denoted and defined by and defined by here P R A equal to X belongs to X such that D of XA less than equal to R. Okay. Then this one with the closed wall. Okay. Now we're going to an open wall with center A and radius R is denoted and defined by BR A equal to X belongs to X and D of XA less than R. Okay. Then what happened? Then we also discuss further in norm space. Okay. That means we know about that. Now in norm space, how this closed wall form and how this open wall form. So we write here, let X norm be a normed space. Okay. X norm be a normed space. Then define dxy equal to norm of x difference y. Okay. Then what happened? Then closed wall equal to what? Then closed wall VR closed A equal to those x belongs to x such that norm of x difference A less than equal to R. Okay. And open wall VR open A equal to those x belongs to A such that norm of x difference A less than R. Okay. Then we also discuss next portion. Next portion is that if A equal to 0, then what happens? Okay. That means for A equal to 0, then BR open 0 equal to what? X belongs to X such that norm X less than R. Okay. And BR closed 0 equal to what? X belongs to X such that norm X less than equal to R. Okay. Next we discuss about that this one are bounded set. Obviously this one are bounded set. Okay. this sum ball, B are open ball and closed ball are bounded set. So now it is that portion and going to further discussion of that. Okay. What we talk about here, BR, BR closed A and BR open A, B all bounded set, bounded sets. Okay. Now we're going to discuss about that. Let's see be a subset of a norm space. Let's see be a subset of a norm space X norm. Okay. Then C is said to be bounded. Then C is said to be bounded if there exists a constant, if there exists a constant r greater than 0 such that r greater than 0 such that norm of x less than equal to r for all x belongs to C. That is, this implies that C subset of B are 0. Okay, that means this C we have said this one is bounded, implies that this is subset of some closed one. Okay, obviously we know about this one. These balls are bounded, we all bounded sets. Okay, now we're going to further discussion of that. Interior point, we write here now interior point. Okay, so let xd be a matrix space, let xd be a matrix space. Okay, and C be a subset of X and C be a subset of X. Then X belongs to C. Then X belongs to C is said to be an interior point of C, an interior point of C. Okay, there exists r greater than 0 such that B R X subset of C. Okay, now we're going to discuss some of another portion. Okay, just X belongs to interior of C means X contain one ball, this contained in this set C. Okay, then we call about X be an interior point of C. Now the collection of all interior point of C is denoted by int C. Okay, we write it now. The collection of all interior points of C is denoted by interior points of C is denoted by in C. Okay, in C or C interior, and obviously int C subset of C. Okay, now we're going to discuss about open set. Open set. Okay, let C be a subset of a matrix space XD. We known about that. Let C be a subset of a matrix space XD. Okay, then C is said to be open. Then C is said to be open if interior of C equal to C. Okay, I think not a problem at all. Okay, we now erase that portion and going to further discussion of that. Right here, closed set. Okay, closed set. Then C be a subset of a matrix space XD. Let C be a subset of a matrix space XD. Okay. Then what happened? Then C is closed. Then C is closed if X different C, that means C complement in X is open. Okay, that means interior of X different C equal to X different C. Okay, again we're going to limit point. Then what? Let C be a set in a matrix space XD. Let C be a set in a matrix space XD. Okay, and X belongs to this capital X. Is said to be a limit point. Is said to be a limit point of C if any neighborhood if any neighborhood of X contain a point of X contain a point Y belongs to Y not is equal to X belongs to C. Okay, let C be a set in a matrix space XD and X belongs to X is said to be a limit point of C if any neighborhood of X contain a point Y belongs to C. Okay, That means we also discuss this definition in different form. Okay. Now we're going to convergence of a sequence in matrix space. Okay. Convergence of a sequence in matrix space. Let Xn be a sequence on a matrix space XD. Let Xn be a sequence on a matrix space XD, on a matrix space XD. Okay, and X belongs to X. Then Xn converges to X if for each epsilon greater than 0, for each epsilon greater than 0, there exists n0 belongs to natural number such that d of x and x less than equal to epsilon for all n greater than n0. Okay, this means that if xn converts to x, okay, that means xn, we write it here. Now we write it if xn converges to x belongs to x, then limit n tending to infinity d of x and x equal to 0. Okay, now we also discuss convergence in norm space. Okay, convergence in norm space. Here strong convergence, that means in norm space convergence divided into two parts. Okay, strong convergence and weak convergence. We now discuss about, first we talk about strong convergence. Okay, then further we also discuss weak convergence. Now we also discuss strong convergence. So we write it now. Strong convergence in norm space. Okay. Then we write it now. Let x norm be a norm space, and xn be a sequence converges to x, and xn be a sequence converges to x. Okay, then what happened? Then if for each epsilon greater than 0, there exists n0 belongs to natural number n such that norm of xn difference x less than epsilon for all n greater than equal to n0. Okay. Then we call about it xn converges. That means xn converges strongly to x. Okay. We erase that portion now. Next we're going to discuss about that in Rn and in Cn. In Rn and Cn, strong convergence and weak convergence are same. Strong convergence equal to weak convergence. Okay. We also discuss this property of, that means now we also discuss some property related to strong convergence. Okay.